Alright, time for another draftphysics.com, debatephysics.com also, but no one to really debate. So we'll just try writing papers and then see if somebody can write an explanation for why anything stated in any of these papers is incorrect. So this should be the third video with an appropriate title and defining a basic, simple idea that should be able to write it in a reasonably short paper, an Einstein style paper, and just make the proposition to be knocked down that here's a simple explanation for a fundamental action in the universe, something well documented, charge, and they have no explanation. So in this case, instead of fighting nonsense like entanglement and interference and superpositions and all kinds of nonsense, the argument is just against nothing. They have no theory for why electrons and protons have the character they have, this opposite character, where they repel like and attract to the opposite. The protons attract electrons, the electron attracts proton, but they repel. Electron repels electron, proton repels proton. And I'm saying a simple explanation that just deals with the fact that we know there's known quantities in the universe. We know there's force stuff, light, for example, moving the speed of light, and that gravity moves the speed of light, and that all magnetism moves, everything moves this speed. It's really the speed of force, and that this force is what's interacting between electrons and protons. So somehow the force has to have some character, something about it that makes it possible for it to create this repulsion and attraction. So you could start with just the simple diagram. Now, Maxwell didn't use color, okay, as a way of explaining, but many physicists have, okay. So they'll call an electron one thing and a proton another. And the idea will be is they'll basically say that the proton is got outness, and they'll say that the electron has inness, okay. Now, that sort of explains attraction, but it really doesn't work for repulsion. I mean, obviously, two things that have inness, okay, aren't going to be repelling each other, and two things withoutness, they might, but the point is it's not a universal idea. The concept doesn't go anywhere, doesn't work as just a statement, and has to be more to the mechanism. It can't be just some idea that electrons consume ether and protons produce ether. That explanation won't work. So you need something better than that. All right, so the simple argument is there's two kinds of force in the universe, okay, that matches the two kinds of matter. So you have electrons and protons, and then an electron and a proton very close together is what's called a neutron. So a neutron is really just these two things attracting to each other and becoming very close. That's a neutron. So a neutron is really just a hydrogen atom without any action, with low energy, you could argue. So that's the simple point, is that you have two kinds of force, okay, plus and minus, north, south, however you want to describe it, and two kinds of matter. The matter's dead, it doesn't move, doesn't have any action of its own, and the only way it can be moved is it has to be hit by force moving the speed of light. Now, the simplest example would be there's an electron in the universe. Let's just say the universe is just full of this force stuff, and it's all over the place. So I could go, right up there. You see a little bit of it right there. See it up there? The whole universe is just full of that. So there's force moving in all directions in the universe, and anything sitting in the universe is basically going to be hit by stuff heading right for it. From all kinds of different locations, whatever. It's going to hit it, and there's going to be essentially an equal amount coming from all directions. And everything's just going to be pushed into a little ball, you could argue. if you just took it all as force that was imposing a momentum. And frankly, that's what gravity looks a lot like, right? You're sitting here on the Earth, you're being pushed into the Earth, and all you really have to do is explain where the extra energy went. And my argument is it goes to making heat. So the center of the Earth is molten because that's where the extra energy went. That's why there's less energy coming out of the Earth than went into the Earth, because there's a bunch of it trapped, still moving. And it would take, like, let's say if I turned all the gravity off and I turned all the mechanism off creating the heat would take a while to dissipate. There's a whole bunch of it. So the fact is the Earth is in a constant deficit of a certain amount of energy, never gets to the surface because it has to maintain the temperature inside. It has to maintain it. It has to keep fueling that fire. The fire doesn't burn forever for free. It has to be fueled by a constant pressure. All right, anyway, that's sort of a separate subject, but it just shows how it's all related, frankly. So the electron is sitting in the universe, getting constantly bombarded, and the simple argument is that it's going to move if I change how much it's getting hit from one side versus another side. And the change is going to be basically just like you pushing a rock. So I could make the rock 100 pounds. And it'd be, if you were going 10 miles an hour, let's say you weighed 100 pounds. Okay, the argument would be is that you'd split the difference. You'd end up going half your speed. So you could just argue that we know the force is moving the speed of light. And when it hits an electron, it's going to give it a quantum of energy, a bit, an amount, proportional to all of these particles have exactly the same mass. And so all you can do is change their velocities. And you can't change the force's velocity. That's the speed of light constantly. So the momentum the force provides is always the same. And the simple argument is you can have it like high frequency light. You can have a whole bunch of it in a small amount of space, or you can have an amount in a big amount of space. And obviously one is going to have more energy than the other. Because of the fact that it's more energy per unit of time or space. All right, so anyway, so the simple rule is, the electrons are sitting in space, the protons are sitting in space, they're constantly being bombarded by a force, all right, and all there is to define is what happens. And I'm saying there's just three interactions. So it's two kinds of force, two kinds of matter, 2 + 2 + 3. There's three interactions technically. So what can happen is the electron sits here and it gets hit by a piece of electron force. The electron force, like a Sisyphus boulder, okay, Sisyphus doesn't just push and then walk away. Sisyphus has to keep pushing for the boulder to roll. Okay, so the idea is the force has to stick to the object, become part of it in some way. And now it will travel some proportion of that speed. So let's say if the boulder is 10 times the mass, then it's 1/10 the speed of light. If it's 100 times the mass, then it's 1/100th the speed of light. It's some number like that. So for each bit of force that hits or sticks, it gains proportionally an amount of velocity. And so we could just say 10% for the sake of argument. All right, so it sticks and it moves in the direction the force hit, and okay, pretty simple. Now, if a second piece of force hits from this side without anything hitting from the opposite side, that is anything extra, then it sticks also. So then the piece can be going, 20% the speed of light because it has two pieces of force stuck to it. And it could have 3 or 4 or 10. And so a gamma ray could push an electron very fast because they would all pile up. The gamma ray would essentially pile up behind it and provide a lot of motion, percentage of speed of light. So let's say that's taken place. You have this extra amount behind an electron. And let's say now I do send another bit the opposite direction. Well, if it's already moving in a direction, the simple argument is going to be the new piece of energy will hit and reflect because this has more momentum. and then a piece of the energy it had will also reflect. So if something comes in this way, energy, that piece will reflect back to the universe, and one of these pieces, the last one presumably, will leave. So with that simple mechanism, you conserve the motion of all the particles. So all the particles, all the force pieces never stop moving. So they're either pushing an electron or they're free, flying through space. Those are the only two conditions a force bit can be in. So these little bits of force here, okay, the little bits of force can only be in two conditions: pushing an electron or a proton, or freely moving through space. That's it. Those are the only two conditions. And so in one condition, they're moving the speed of light when they're not pushing anything. And when they're pushing something, they're moving who knows what speed. It depends on how fast the thing they're pushing, how much other force is pushing it. So if there's a lot of force pushing it, then maybe they're only going 3/4 of the speed of light, so they're not slowing down that much. Okay, but if it's an electron that doesn't have any force pushing it, then it could be quite a lot of work, okay, to push it anywhere. All right, so obviously an electron can only move in one direction at a time, so it can go in one dimension at a time. So it can have energy in this dimension, it can have energy in this dimension, it can have energy in that dimension, but it can't have energy in all 6 subdimensions. It can't be going forward and backwards. It can't be going up and down. Okay, so there's no piling up of force on both sides. It either has a bias in one direction or it's neutral, but it doesn't have anything in between. It's either going somewhere or it's going nowhere. Okay, in every dimension, in 3 dimensions, basically. All right, so with that simple explanation of the motion, all right, you can understand how electrons and protons get moved. So the proton is pushed by the proton force. The electron is pushed by the electron force. Okay, so the green pushes the green, the red pushes the red. So now what happens if a red force hits a green? Okay, so if a proton force hits an electron, right, it doesn't do anything. Doesn't push it, doesn't make it go anywhere. It just goes straight through and it comes out reoriented. Okay, so its orientation changes. It goes from being a girl to a boy, or from a boy into a girl, however you want to, whatever kind of silly analogies you want to use. But that's what happens. It changes. So basically, now you can just draw now you have the 2 simplest interactions. The only other interaction, right, is I did reflection, did absorption, sticking, and this one. That's it. So you have 3 possible scenarios. So obviously it's the same for the proton force. So when a proton force is sitting here and a green thing hits it, okay, it's going to come out a red thing. All right, now with these simple rules, with those simple rules, right, you duplicate, in a sense, Maxwell's drawings perfectly. Okay, you end up with 2 distinctly different objects, okay, that produce, at the inverse square law, a force. So all the red energy that goes in comes out green here. So we know that's all green. We know it can only reflect and it can only stick, so we know that's all green. So this object sits in this space and just radiates, in the case up here, blue, and the other one will be radiating just red. Okay, so the 2 things are radiating the opposite forces. So whatever goes in comes out red. Whatever goes in comes out green in this case. So obviously any red force over here that's trying to get to this object can't get there, right? It's going to get converted into green force. And the green force is neutral, and so it's just going to come out red force. So the red force starts red here, it turns to green here, and it turns back to red here, and nothing happens here. There's no momentum. There's no impact here. No red hits this. It needs to be red to move it. And nothing, the same is true here. A green force pushing from this direction can't get to this green here. So it's completely blocking the force, in a sense. It's stopping a green from getting to it, because it's going to get converted to a red, and then the green will pop back out of green over here, but nothing's going to happen. There'll be no pushing force. So obviously the pressure here would be very low pressure. No pressure, essentially. Nothing can get in here. Okay, now you could have some angle like this. You know, you could have something could fly in from this angle and hit the red, right? But the closer the two objects get, you can understand less and less can hit from any other angles because they shadow each other. And so the force just gets stronger and stronger. The amount of attraction gets stronger and stronger because more and more of the universe is closed out, and the only universe that can get to them is from these opposite sides, and the opposite sides can't make a bit of pressure. And you have exactly the opposite circumstance when two electrons or two protons are facing each other. It's nothing but pressure. It's high pressure, because now every time a green force comes in that would have not affected this thing, right? So we have a green piece of element of force over here. The green piece of force is now going to be converted into a red piece of force here. So it's creating more red to hit this one. It would have been inert, but this one has made it now active. And so now that's a real piece of pressure. And likewise here, all the green force that comes this way is going to be converted into a red force. So you have a high pressure here, very high pressure. So between the opposites, you have very low pressure. Between the likes, you have very high pressure, and the pressure gets higher and higher the closer they get to each other. Means, you know, they had to have force to push them towards each other. And so these are all reflections. So the red bounces off this red one, bounces off that red one. They just keep bouncing until they can get them moving the opposite direction. So as long as they're moving towards each other, it's all reflections in here. And it's not until they start to move away from each other that they start to stick and add momentum. So they can't add momentum. They can only slow something down when it's moving towards. And as they're slowing it down, what also is happening is they're reflecting. So the force bit just keeps reflecting back and forth until the two objects stop moving towards each other. So it becomes a very high pressure. So with this simple explanation, you duplicate exactly how electrons and protons function. It's exact. It's complete. It's a complete diagram of charge. It's exactly what charge does. It's explained right there with those simple 3 rules: reflection, absorption, and identity transition. Let's see. Switching the identity of the force, however you want to describe that. And that's it. It's all you need. That simple mechanism duplicates the biggest mystery in physics. I mean, this is the biggest unexplainable. All right? They have explanations for other things that are wrong, okay, and silly, but they don't even have a wrong, silly explanation for charge. They just say it exists. They don't have any way of explaining why electrons are different than protons. And the difference is this simple. The difference is, you know, this red and green could just mean, you know, one of them can see a force as triangular and the other one sees it as square. It could be just a geometric rule. So what makes the electron change the force bit, the orientation of the force bit, into something else can just be the difference between square and circle. It doesn't have to be red and green. Obviously, I'm just using that as an illustration. But all you need is 2 kinds of force: square triangle, square circle, you know, hollow versus solid, you know, some kind of distinguishing feature, and that the 2 elemental matter bits convert that simple feature. They just convert solids into hollows or hollows into solids. They turn red checkers into black checkers. That's simple. And it perfectly creates the attraction and repulsion. And it's that simple. So I'm just saying the odds of it being the wrong answer are pretty thin, considering how could you make a simpler explanation for the event of having both attraction and repulsion, except this. How could something be diagrammed that could have fewer moving parts, fewer all you have is three interactions: reflection, absorption, and transition. That's it. You got three little things that could happen, and you duplicate perfectly charge. So I'm saying it's high probability. I'm saying if you're a reasonable or fair cop, you have to concede it's hard to imagine how it could possibly be any simpler than that. Okay, to create the semi-complex interaction that requires you to have complete hard attraction between the opposites and hard reflection between the similars. All right, let me take a pause. I think that's enough. Should be enough. All right, I guess I should add. So I have a couple of different partially finished simulations. I've shown them. It works fairly well. I mean, it's a one-dimensional simulation, so you can sort of understand that you lose the power of the inverse square law because you're only using one dimension. You're not concentrating the force in two dimensions, so you lose the advantage of the squared function of the inverse square law in creating the force. But the point is that the electrons and protons attract, they stick to each other, blah, blah, blah. It all happens in the simulation. And obviously the same like particles repelled. You can see it. You can understand from the drawing. There's no choices. The simple three rules provide no alternative motion. Okay? So, it's one of these things where you can calculate it, which brings up what's his name, Mathematica guy. Anyway, so this is so simple. If he put this into his supercomputer, okay, and you ran it, it's going to do this thing where it's going to end up creating these, positive negatives through these dipoles. They're going to start sticking to each other. All right, and then they're going to have to stick to each other with the repulsive elements in there, and they're going to start creating geometry, because there's only certain geometry where you can start crowding them into each other, because they're going to see each other and be repelled by the likes and attracted by the dissimilars, and they're going to have to do that, providing space to do it in. Okay, and that's why there's elements and there are certain configurations that will be durable and configurations that won't. All right, so the bad news is one of the people doing the simulation chose to no longer accept the indignity of being a living organism. And so, that simulation, so I think I have the rights to it pretty much. I can't remember the program he used to write what he wrote so far, so maybe I'll make that public, and if somebody wishes to build on what he started, that would be appreciated. Otherwise, there are others who are still enduring the indignity of being on Earth, and but they're not doing it comfortably, so they can't really devote a lot of energy to this project, and so it's been a little slow going. But the point is I have shown it. I can, that's what the little stuff up here is from. Okay, that's just a computer generating by these really simple rules the field of energy. Okay, and the field of energy is just straight line force. There's no waves in any of this. Okay, there's nothing waving anywhere. There's no wave function. Okay, there's just a universe obeying really simple push style rules. And again, the energy is permanent. and all you can do is some of the energy can be used to push matter around. But while it's being used, the universe is a little cooler because stuff isn't moving as fast, you could argue. All right, anyway, that's probably enough. Again, so I'm not directly opposing their theory because they don't have one. So in this case, but clearly they want you to believe that these are just elemental functions, that somehow it just magically happens, because they have no clue how any of it actually works. They have a bent geodesic to explain gravity, and that's just mush, just some pretend something that doesn't exist, space, is somehow bent. It's a non-answer. And they can't use it in this case because there's repulsion involved here, and they can't make that out of bending space. So anyway. Right, simple answer, solves the problem, completely works, stays completely consistent with the elements we know exist. We know there's stuff moving the speed of light. We know it carries momentum. We know there's elemental matter bits. The electrons and protons are for sure's. And I would argue that everything else is made up mush, but the neutron, it can be understood as it decomposes into essentially an electron and proton, so you can argue that the neutron isn't neutral, it's a dipole. It has both properties. And a dipole really close together, you can understand. Look, if I take a red light and a blue light and I put them very close together at a distance, you're just going to see purple. So it looks like it's neutral, but it isn't really neutral. All right. So, that's enough. The universe has to see, everything in the universe is seeing, okay? And it doesn't have to see it. Just as we know there's radiation hitting us right now, we know that it's all doing the same thing the light is doing, okay? All kinds of frequencies, all kinds of bombardment. And that's all everything in the universe is doing. It's communicating with a speed of light force. Everything sees other things. Electrons see protons, and they see electrons because they see the force that's reflected off of them. They see the force they emit, okay? The force that radiates from them as a consequence of what had to already hit them, okay? I mean, nothing's radiating anything that comes from nowhere. All of the energy has to have been somewhere. It's all got a history. Every one of the little force bits has a history. It's been somewhere, pushing something or going somewhere. It might be traveling, like some light travels billions, hundreds of billions of light years through space. Hundreds of billions? No. 13 billion maybe. A very long traveling distance. Okay, and it might hit a few hydrogen atoms. It might get scattered a little bit, the energy. But the fact is that bit of force, they all have a history. They've all been here for the 13 billion years. They've all been somewhere. And every piece of electron and proton has always been somewhere. Okay, it all has a 13 billion year old history. And that's all the universe is doing, is exchanging, is absorbing and emitting the force. It's at a kind of equilibrium. And, you're just taking force and making it move matter, or releasing it from an obligation to move matter. I needn't say more. I made this longer than I needed to, frankly. All right, so I haven't written this paper yet. All right, so this is the third paper. And yes, I'll leave a link to the paper that will be, okay? But yes, I haven't written anything yet. It's so simple, but it's such a bitch to explain stuff that you really have to draw. So I guess I am, I'll try, maybe I'll put some drawings in the paper just because it's just almost impossible to explain it without a drawing and such. It certainly would take a lot more words without a drawing. Something like that anyway. Alright, so till the next time and such and so forth and whatnot.